Hey guys, welcome back. So, a few things have come in and I'll take you over what they are and where they fit into the scheme of things, and a few updates on a couple other bits. Anyway, grab yourself a drink, a few little snacks, and that comfy old chair, and let's get on with it. Right, so a couple of things. One is the Pico expander may have a lead on a couple of things that was wrong with that. I didn't realise that he was using an AHCT 14, a 7.4 series one. I was just using an HT, so yeah. Or an HC, one of the two. But anyway, yeah, I didn't realise that that's what he was running. So that could be where my fault may have been, because apparently when I was talking to Stephen, he says if the 7414 wasn't in there, he had the same issue. The machine would just freeze and wouldn't boot up. So I am picking that that could be the issue. But I don't have the boards here with me at the moment. They're with Stephen. I've sent them down to him because he's got a working one, and so I sent them to him so that he can then try his parts in my boards to see if they work, and then if it works, then take them out one at a time to find out where the fault was. And I'm picking it probably as the 7.4 HC that I had in there, rather than the AHCT. So yeah, anyway, that's where that is. Box turned up. This is part of projects I'm doing. Now there's some really cool projects coming up that you want to keep an eye out for. I've started making a GitHub repository and page for the 3-in-1 PC I'm building. It is private at this stage, and until it gets to the point where it has been certified working, etc., then it will be made public, and I'll put it on here for you guys. But just a couple of things that have come back. This is the Pico board. Now this is the one where I've made 4 layers rather than 2. So I'm going to see if that makes a difference, but I'm picking that it's probably that chip. I don't have any of the AHCTs 7414s, so I'm going to have to get some. So that's what those are, and that's the 4-layer board. So I'll see how they go. And another couple of project boards. This is the beginning of the subsystem board that I am building for the 3-in-1, and this is another little project that I started because someone said to me, with the Pico expander, be careful, because some of the 7.4 LVD chips could be fake. They could be HC or LS rebadged. And I sort of thought, well, how am I going to tell if they're not? So this is a project in the making. And it's the first build, so I'm going to put it together. And I looked at wanting to make something so I could check those to see if there's a way of just finding out if they're fakes or not. And so I came up with this. I know there's a lot of chip testers around in that, but this goes a little bit further than that, and it does multi-voltages as well, as well. And you can select up to what type of chip you want to run, and it runs a menu library of ICs that can be updated as well. And it's running a Pico, just a standard Pico. It's not a Wi-Fi Pico because it's a standalone unit. I don't want it Wi-Fi. Couple of other things was, another part for the testing of the 3-in-1 boards was, this is to go in where the cartridge connector is, and this gives you all the address lines to tell you what things are doing what, and in such a way that it can be programmed to give you a certain strobe of information to tell you what it's doing. So it's just a real down and dirty way of checking if everything's working or not. So that's a board that I got in with the last lot, and I've made that one up. but it's getting there. So I just got a few parts I'm waiting on to turn up. I've got all the ones with this one. Just this one here, I'm waiting for some bits to come in, and I do have all the bits for this, but I want to wait until Stephen gets back to me. And if he says it's the 7414, that's the issue, then I'll build one of these to see if they work just as well. But I don't want to go down that trap of soldering in more edge connectors and stuff like that that's going to start, and sockets and things like that. You know, people say, oh, they're not dead, but those edge connectors can be up to $4 or $5 each. So once you're doing 3-4 boards and they don't work, it gets expensive, and they're not the easiest to get out. They're a very tight fit. So if I was going to redesign this, I'd probably make the holes a fractional bigger, because they are a very tight fit for those edge connectors. The other thing I was thinking is some people have had issues where if they don't push it into the back of the 328, it won't connect or won't fire up properly. So I'm thinking on the next one I might push the edge connector out a bit more, just so it just goes through the board, and then solder it on then and see if that fixes the problem with that. But the other way you can do it is just by adding in a little daughter board to go on there, or even build a plug-in board, so you can just put a standard 2x25 way, and then have a socket on the other one that plugs onto it, that then plugs into your machine. You could do something along those lines, just make it like a little bridge board or daughter board to make it extend further. So that's what we've got going. I think the next project I'm going to look at doing is this. Since I'm having to wait for parts for this one, and I don't want to touch that one for now, I can't really do anything on the 3-in-1 system, because I'm waiting for a couple of parts for that board. But I've got most of that stuff here. It's just a couple of things that I had to order in that were being a little bit of a pain to get. So I've got those coming in, but I'm pretty sure I've got everything here for this one. And this one I've made it in such a way that it is all through hole, as is the same with these ones are. That one is through hole and surface mount. Some of the boards I'm building at the moment, I'm doing surface mount for some stuff because it's easier to get hold of. A lot of it, if I can, I try to do through hole to start with, and then once I got it down to a point where it'll work, I can then shrink it down into smaller boards or combine the boards to make them SMD rather than through hole. But if I can try to do it mainly through hole, then more people are going to get the chance to build this than if it's SMD, and they're sort of shy away from the SMD. Alright guys, so anyway, that's where we're up to, and this is what I'm going to get on with. So I'll get this stuff out of the way and we will have a look. Right, so here we have the boards. Get rid of the packaging. And it's pretty basic. The only SMDs that are on here are the protection diodes. They were tiny wee ones. I've been having issues with KiCad with footprint sizing with components. It used to be really good. You could grab a component and have the footprint associated with it already, drop it in, away you go. Now it seems to be everything's on there. Very few of them have their footprints associated. You've got to pick it yourself. So unless you know what it is, yeah, it's not easy. Now this is meant to be a ZIF socket for here, but for this first iteration of the board, I have gone with just a standard IC socket, just for testing. I didn't want to solder in one then find there's an issue, and yeah. So anyway, that's what I've got there, and these are probably too big for the resistors anyway. That's probably miles too wide for them. But as I said, this is just a proof of concept board, and we can go from there. So most of the stuff I'm going to put in sockets, any of the ICs. The other stuff should be easier to pull off if I need to. The Pico is going to be in a socket, so the only one will be these. But the protection diodes are really cheap. I mean, it's about $4 for 100 of them for the surface mount ones, and I thought, for the price, why worry? And I mean, if I wanted to, I probably could do this with the hot plate if I wanted to go down that route. But I'm just going to solder them by hand. It's only 2 at one side, 1 at the other, so that they're easy enough to do. The magnifying glass and a fine tip on the soldering iron. But yeah, that's what we've got. So there will be information up on this video about it. I will put some screenshots and that up there for you guys of what the machines are. I'm not going to put up the Gerbers or anything like that as of yet. As I say, I want to check that this is functionally correct. Most of the information is actually silk screened onto it, but when I release it, I will also release a very, very basic manual. The GitHub repository will have everything from concept to building it to pitfalls and traps to revisions, etc. So you can see what I did as I went along and built it. And most of my GitHubs are going to be that way when they get turned into public. So another nice thing with this is I'm going to probably release it as a shared project on PCBWay as well. I did get these done at JL PCB. A lot of my boards now, I'm finding it's easier to go with a 4-layer than it is to just 2 layers. And the analogy behind that is you can have data or signals on the front, you can have data and signals on the back. Your next layer down is a ground layer. So that's all your grounds, and what that does is shield the front to the back. And then your third layer is your power layer. So that's the layer where all your power tracks, your 5, your 3.3 and 1.2 and whatever runs. So what I do with these boards, if they're a split voltage board, what I will generally do is to run the board in, put most of one voltage one side and leave the rest of the board for the other. Or if you're having different voltage chips around the board, I will generally run a 3-sided or a 4-sided loop around the board and then have the inside one as the main voltage. So if you needed 5 volts and 3.3, I'd run a probably millimeter wide 5 volt around the outside of the board, and then all the inside would be 3.3, because that's what most of the chips run, and that's where you want most of your voltage for connecting to things. So that would be the way to do it. Or if you only had your 5 volts on one side, you can run it just on that one side. Or if there's only a couple of things from your connector, wherever your power's coming from, you can run your 5 volts directly to it from there. Alright, so anyway, that's us, and that's what this is. So I will get the bits together and I will give you a breakdown on what happens with it after this. The other thing was, as you may have seen, this is the keyboard for my 3-in-1, and this is running 2 microcontrollers on it, and this is actually a helper microcontroller, but this is for doing all the joystick port information and stuff and handling it. But that's what that is, and you'll see in my first build that comes up on here, that's the keyboard there when it's all said and done, and standard keyboard. And you'll notice too that there's no Pico here. And why there's no Pico here? Because the Pico's under here, and that's just for keyboard height, so that when it goes in, this MCU's fine, but it just, with the other one, it just made it too high, so when this goes into a case, it'll be lower down. So that's where that bit's up to for now. So I'll get along, get the bits together, and start putting this together. Okay guys, so here we have it, and as I said, it is pretty basic. The power will run from the Pico. A later iteration of the board, I might have a separate power supply to run it, but a Pico, Raspberry Pi Pico. I have the 2350. You can use the 2040 which is fine. Just the 2350 is a bit better, a bit more power, more storage, and so forth. And price-wise, it's not much difference. You could put the W on there or the W2 on there. It's up to you. Whatever you want to put on there. I've not set this up to use wireless, but yeah, it's up to you what you want to do. It will have the option to, from the USB cable, you can plug it into your PC, and on a terminal monitor on your PC like TerraTerm or PuTTY or something like that, it will give you more information about the chip you're testing as well. So the OLED is only for basic information. But anyway, so a Pico, our OLED screen. Now there's the two different sizes you can use. This is the slightly bigger one. This is the 64, I think it is. Yeah, you can either go with the 32 or the 64 line. For the price, I just got 64s. That's what the board was made for. We have a 2N3904, just generic transistor. This is a driver for the piezo. Of course, we have one standard passive piezo, and this is the 15 by 7mm. And we have 4 decoupling caps, 100 nano or 0.1 UF, and these are average 50 volts, I think they are, for the ceramics. And the MCP 2307, that's our microprocessor. There's 2 switches on the board here, and these are just the standard 6mm by 6mm push buttons that you get in most of the projects used. Now you can put in whatever height stems you want on them. These are 6mm, but you can put whatever you like on it. And there's a header switch here, which is a 2 by 10, I get it, 2 by 8, which is a 16-pin header, which goes to the rotary switch for selecting what size IC you're using, and that's one of these switches, and these are cheap as well. And these are a 3-pin 4 selector, so it'll select 1, 2, so from one position you go 1, 2, 3, so the opposite direction is off, so you're starting from an off, and then you'll go 14 or 16, 18 and 20, so, or 14, 16, 20. It'll select which is the output you're going to for the socket size, for the chip size, sorry. Of course, a ZIF socket, this is the 20-pin ZIF. Now later on I might look at, when I do the second iteration of that, I might be going to the 28-pin, slightly bigger socket. I just want to make sure that all my standard chips will fit in here, which I think you have to get what's called the narrow body. These are the wide body. The narrow bodies are this wide, but the center is the width of the 20s, so you can put the smaller ones on it. The other option is if I make some more real estate, I could probably put both of them in there, but one would be better. So that's just the other thing to look for. You don't have to use a ZIF socket if you don't want to. You can use a tuned pin socket or a dual wipe standard socket. It's up to you. Now all these ICs and the Picos and that, if you want to, you can put them into sockets as well. Same as this, you can put a socket on the board and plug it into it. I am going to make some standoffs for this. So I'm going to make a case for this as well. So that's just something to be mindful of later on. Capacitor, we need one bulk capacitor, which is 10 UF, and this one's a 50 volt one, so it's only one of the small ones. RGB LED, and that's a common cathode. And we have one 2.2K, one 100K, one 10K, three 330 ohm, and 20, I think it's 20 or 22 4.7Ks. and that's our piezo, of course. And as I said, these are the switches. These are just your standard 6x6 tactile push switches, and you can get them all in different varying heights. This was a kit I bought from AliExpress, and as you can see, you can just get all different. They're all the same 6x6, they're just different styles for the heights of how high you want the push button to be. The other thing I'm going to need for this is, because I couldn't get the right footprint for the switch I want to use, I just put the header pins in it, and I'm just going to make up a JTS connector with some ribbon cable to go from a plug from here and solder into this. So if I do make a case, I can move this to where I want to in the case without it causing any other issues. The other thing I might have to look at doing is, on a later board I might do it as 2 boards, and I will put the tack switches and that on its own board, maybe along with the ZIF socket, and then that way, and maybe the LED on their own little board, and that way they can be on the case and this can go anywhere underneath, and it doesn't have to try and line up with the heights, etc. Might be something I'll look at. I mean, I could always, I don't have the power switch yet. That is an on, off, on, and that's just so when you're switching voltages you aren't jumping from one to the other and spiking it. So you have to go 3 volts off, 5 volts off, 3 volts. So you can only be in one direction at one time. If you're in the middle, there's nothing. I haven't got that, so I'm probably going to use a couple of header jumpers and just some jumper pins for now to set my voltages. That's about what I'm going to look at for now for those. Alright, so that's what we've got, and I'm going to go through. I'm going to put tuned pins in the board for the Pico, just so I don't, if a board gets to be rebuilt, I'm not being stuck with this one with the Pico being in it, and it's easier to unplug it and move it on to something else. Resistors, the passives I'm not worried about, nor the LED. The ZIF socket I am, and what I may do is just put a dual wipe socket in here for testing. I'll put a socket in here for the LCD. The buzzer I'm not worried about, it's only 2 pins. I'm putting a socket in for the MCU. And the tack switches I'm not worried about either, nor the diodes either. They are cheap. They're cheap, so I mean, I'll probably get a pile more of these anyway to go on the boards. Alright, so that's what we've got. So I will put all this together, and then I will come back and show you the completed board. So getting there, guys. As you can see, I'm down to making the cables up for the switch now, and last cable to make up the connector to go onto the header connector, and then it's just soldering these onto the plug, which I'll get to. But as you can see, the board's come together quite well. The other thing I've got to do is put the pins, the round tuned pins on the Pico, because I put round tuned pins on the board. But as you can see, it's the board. As I said, I had a IC socket I'm putting in here for now. I don't want to waste a ZIF. I don't want to waste one of these ZIF sockets putting it into the board and then having to try to get it out again. So yeah, that was it. Tricky little thing was these little diodes. I found the easiest way to do it was to put a bit of flux and a dab of solder on where the top single pin goes, and then with a pair of tweezers I could hold them in place with one hand, come in with the soldering iron with a fine tip, and I put my little wee fine tip on it, come in, heat it up, and then I could slide it with the tweezers in the back, and I could slide it to where I want it, and then just wait a few seconds with the iron away for it to solidify, and then I could come in and hold it down with the tweezers and just heat the end up to make sure it's flat, and then do the backs and that. And it all went really, really well. There's only a couple that sort of got a little bit twitchy there where I didn't have it quite right, but it all went on fine. The rest of the stuff all soldered in straight and easy. So I put a socket in for the MCU, I put a socket in for the screen, I don't have the switch at the moment, so I've put in a couple of strips of jumpers, and I'm just using a pair of jumper blocks to go on them for now. Set it for 3 volts, and then I'll turn it off and I'll switch them over and set it for 5 volts if I need to. All the rest of it's there, the LEDs, the switches, the buzzer. So it's all sitting there ready to go. There is a couple of things I'll change on version 2, and that's to make the silk screen a little bit wider. It's a little bit narrow and just goes by the board here. With the zip socket, it'll take out the first one so you couldn't read it. So I think all that printing can go up, and probably the whole zip socket can go up a little bit as well. If not the OLED can come down a wee bit as well. But anyway, so yeah, that's all looking pretty good as it is there. So I just got to finish this off, and then I'll come back to you when I've got the switch all wired up. I just have to have a look at it and see which way round I had which pin going to which one of these, so I can wire it up correctly with the header connector, and then we should all be go. Alright, so I will see you back here again shortly when this is all wired, and what I'll do is then we'll go through the programming of the Pico and the soft basics of the software, and then from there the next update I will be doing on this will be once I've probably got all the software done and to where I'm happy with it. There will be probably updates coming out for the firmware of this as well that may support more chips, but then once I've done it, it's up to somebody else. If they want to build on it and add in extras, etc., then that's up to them. Okay, that's me for now, and I'll carry on and finish on this cable and wire this up, and then we'll carry on from there. Alrighty, see you soon. So it's been a few days for me, but not for you, and I've done more work on the unit. I have gotten to a point where I have it working, and I've changed a couple of things. There were a few issues, and I'll just switch you over now, and I'll just briefly run it through with you. I've made a few revisions, and there's going to be a revision B coming out to fix the couple of small issues that I came up with. So hang on, we'll just switch over. Right, I don't have the other camera on at the moment, so this was the first board I did and set up, and I had an issue with it, and it was being pulled down all the time, I think it was. I actually got the wiring on the protection diodes the wrong way round, so to fix that I've just popped them off, and now the resistors will be enough for testing, and so that's what I've done. So that was a revision A board. I then found that the resistors were a little bit heavy, and I needed to drop those down as well, and so I went down to, I think it's a 1K rather than a 4.7, and so that's what this one is. This is the revision 1B. So this is where I've gone through and I've fixed up a few of the issues. Now, as you can see, in upgrade number 2, I've decided to go with a rotary encoder. The push button is not enabled on this yet, but it will be. I'm still using the test button down here for now. The OLED is actually installed and working, and as you can see, I have an IC in here. I've gone through and tested all the HC ICs that I have, and I've pulled out, there were a couple that were dodgy, and the rest of them all passed. But this is only doing basic tests. I've got to work on doing, there's going to be like a burn-in test and a gate functionality test between each other and things like that. There's all sorts of tests that I'm going to be writing for this to add into it. The piezo that's on this side here, the little speaker piezo, I've had to change that. I had it as a passive, but running at 3.3 volts, it was not loud enough from the Pico, so I'm going to an active and then switching that back to the microcontroller and freeing up a pin on here for later on. Other than that, the rest of it all is pretty much as is, and of course I've put slightly heavier wire on here because when I was doing all my testing, moving it around, the thin wire like this one here was actually snapping off of here or snapping off of here, and it became a real pain. So I found some old power supply wire. This is too heavy, and I'm finding at times it's actually pulling out of the socket. But I need to get something a little bit thinner than this, but a lot thicker than that. So I'm probably going to look at mucking around with something there somewhere. A lot of this is on flying leads because I am going to do a case and have it all sitting in a case. The same as this in revision 2 or B. This is just a header connector which is going to go to the zip socket, which will be on the top of the case. And over this side now there is going to be, this is all moved down slightly, and over here is going to be a power supply unit for 5 volts in, and then it regulates down to the 3.3 for the Pico, and if the chips need it. Other than that, the 5 volts for the 5 volt chips if they need it through the 5 volt switch. And I do have the switches rather than that, and that's these ones here, and that's this style here. These are fairly cheap. They come in a pack of 5 on AliExpress, and it's an on, center off, and left on, center off, right on. So it's a 2 position, but it clicks as a 3 position because there's only the 3 poles. So, but that's what I wanted that. So you can go 5 volts off, so there is no voltage going anywhere, so you can't spike anything, and then you go 3 volts off, 5 volts off. So that's that type of switch. They come with all the glands and the nuts and everything, the same as these ones do in the packets. So that's what I'm going to be doing with this. I will show you this running in the OLED. The other thing is that I've set it up to run via USB as well. If you want to run via USB, there will be a you can use a terminal software that gives you more information than the OLED does when it's actually testing the chips. So it'll tell you if there's a bad gate, what gate it is, so you'll know what pins are no good. So if you only need to use part of an IC, you know that those 2 or 3 pins are no good, not to use those and use the others. So it's going to give you a little bit more information, but I'm going to have it where it can run about probably 3 or 4 tests on each IC. You can select them. It doesn't need to run them all at once. So you can go through, select the IC you want, you set your voltage, select the IC you want, and then you can get it to do a basic test. Then from there you can actually select it to do the other tests. So you can do a burn-in test or a soak test or a low gate, high gate, or a dead gate, or there's all types of tests I'm going to look at, and it's just the ones that are going to give me the best test for the chips are the ones I'm going to incorporate into it. But other than that, then when I've released this, people can do what they like. They can update the firmware or whatever they like, and if they want to, they can send me a pull request for it and put it up on the GitHub under alternative software for the Pico. Alrighty, so what I'll do is I'll get this all connected up and the terminal installed, because I haven't got it on this machine yet. I'll put the terminal on here, and then I'll just show you this doing a few quick things, and then we'll do a wee bit of a wrap up on it. Okay, so I'll be back shortly. Okay guys, so we're going to plug her in. I've only got it running off the USB until I get the revision Bs, and I build the power board for it. I'm using software called Thorny, and it's a little bit to set up, but it's a term program I use because it's got Python built into it, so I don't have to run a separate Python script or program to do it. What I do is I'll load up the first one for you, and this is the actual software that I'm going to be running on this, and you can't see it at this stage because I haven't got it routed through to the OLED. I will just show you that the OLED is actually working, and as you can see there, that is just a little test screen that comes up with the OLED. Now the information will be from here, will be on here. The encoder will cause it to scan backwards and forwards through the chips to select, but I haven't set up the push button end of this yet. It's just too many moving parts and the wires are going to break, so that part I'm going to leave that, and it's an easy software port over from this switch, like I did with the next switch that was down here on this board, because this had the 2 switches for select next, and then run test. I've decided to go to rotary encoder. It makes life a lot easier. You'll be able to select and then go next test. I may leave the test button as separate, and on here when you select the IC, then you may be able to also, when you push the button, select the type of test you want, which I think may be another way to do it, because then you can reuse the encoder to rotate around to what test you want. But anyway guys, so this one is set up and running. So as you can see, that's a test for the OLED. Now this is your select switch. Now if you watch the LED, so this is off, so there's no LED on. When we turn it from the off position, the first one is red, which is 14 pin chips. When we click it again, we go to green, that is 16 pin chips. We click it again, we go to blue, that is 20 pin chips, and that tells the Pico what group of chips it's actually testing and where to put the ground and the power on the pins. So that's where we're up to. It also works through the power switch here to give feedback to it, to tell it whether it's a 3 or a 5 volt chip that it's working. But when this all gets tidied up, a lot of this will all be incorporated into the rotary encoder. I may switch from just a test button to a test button with a second rotary encoder. I do not know yet, but it is something I'm working on, and it's getting really, really good. I can already do in the vicinity of about 40 I think it is, HC chips that I had on to hand, and as I said, all of those bar 2 were good and 2 of them were faulty. The screen will give you basic information. As I said, you need to run at this stage, you'll need to run a terminal program if you want in-depth information, and that'll just come out through the USB into your PC. To get really good information on here other than basics, you're going to need a bigger screen, more cost, more hardware to drive it properly, etc. So better Pico, so on and so forth. So it comes down to that point, how much you want to throw at it. But for what I wanted to start doing and now has turned into, it is going to be a multi-chip tester. There are other things I'm probably going to look at later on adding to this, but then that will probably be a revision C upgrade, which will be the bigger ZIF sockets again, which are the 28s, and that'll just go into more things. So it may have dual, I might have the dual 20 and 28 pin sockets on it. I don't know yet. Alright, so that's where we are, and as I say, you can go forwards and backwards, turn that on and off. And the new one, as I say, over this side here will have the power supply, and all this will be moved down, and the rest of this will all be in a top case. So guys, that's what I've been up to. Sorry, no software because it's on the main screen and it's a pain at the moment. But just showing you that it is up and working and doing its thing. I've been updating the GitHub for it as well. Revision 1 is workable as it is. It's not where I would like it to be, but it is workable. And I've had to do a couple of little minor bodges on the board, but revision 2 will have all those fixes done to it, so I'm going to order those. I'm also looking at making a top board for it, for a case, and what I'm going to do is have the ZIF socket and the rotary encoder and the OLED and a couple of buttons and stuff all on a top board that can get screwed into the top of the case, so everything you need is up there, and it will take the strain relief when you're pushing and turning things. And then it will just be wires that go down to the main board to plug onto headers down the bottom. So that's where I'm going to be up to with part 2, and so this is the end of part 1. So if you're interested in this sort of thing, let me know, and I'll keep you in the loop, and I'll be chucking out a link to the GitHub page when it's all ready to go. There will be build log, build instructions, bombs, stuff like that. I am going to chuck it up on PCBWay when it's finished, so you'll be able to go on there and order the boards. It is 100mm, so there's no issues with getting the cheaper boards, and the top boards are smaller than 100mm because they're only going to be taking part of the lid. But I thought that would be the best and most cleanest way to have it in a case, because some of the components are up and down in heights, and I just want something that looked nice and tidy. So that's where we're going, but that may still change. You never know. Anyway, that's where I'm up to. Oh, one thing too, if you want to, I've started up Buy Me a Coffee as well. So anybody who feels like they want to throw me a couple of bucks to help with these projects, and if you want to do it, please do. It does help me out getting this stuff into a working position, so then I can upload them to PCBWay and to my GitHubs and that, so other people can make them. Most of the stuff I'm doing is all free. It's all for public use. I do not make anything out of it. The only place might be I might make $1 or $2 every couple of months on PCBWay for my boards, and that is it. But this will just help me pay for the parts to do more work and not having to rely on outside work to pay for stuff. As I always say, guys, you have a great day and you have a great week, and until next time, ciao.